Okay, guys, for today's lesson, you're going to need this sheet that says 2.2e class activity. This is page 63. Okay, page 63. So today we're going to talk about how we take word problems. Maybe they give us a story. Well, then we need to make a table for that, make a graph, come up with an equation. Or maybe they give us a table, we come up with a graph, and so forth. So let's start with the context. First off, it says this problem is about a state fair. You and your friends go to the state fair. It costs $6 to get into the fair and $2 for each time you go on a ride. Consider the relationship between the number of rides and total cost. So that's our two pieces there. Anytime that you guys got a total of something, total cost, total amount, that should really be your Y. Okay, and the number that you're plugging in, that's going to be your X. Okay, so if I come over to the table, remember our X is on the left side, our Y is on the right side. Well, over here we have X stands for rides, my number of rides, and Y stands for total cost. So I'm going to fill that in. Okay, now remember, we always want to start with the 0 as well. So I'm looking at this problem here, and it says, well, how much would it cost to go to the fair if you rode 0 rides? Well, right here, it tells us it costs $6 to get in the fair. So you're paying $6 no matter if you ride nothing. So right there, 0 rides, it still costs you $6. Okay, now 1 ride, you see each ride is $2. So 6 plus 2 gives you $8. Okay, if I went on 2 rides, again, I'd have to add another 2 to make it 10. So we're going to continue this for 3, 4, 5 rides. So every additional ride, I'm adding 2 plus 2 plus 2. So it's going to be a 12, 14, and a 16. Okay, move down to the graph there. Let's go ahead and put our 0 in the corner. Put our X, put our Y, and then label our axes. So X, we can say down here, this is the number of rides. And for my Y-axis, we could say over here, this is our total cost. Okay, checking out our X's. It looks like the highest number we need to get up to is a 5 to graph that one. So it looks like I can probably count every box as a half, which means I can label every other one as one whole. So 1, there's 2, 3, 4, keep going until we get a little bit past 7. Okay, if I look at my total cost is 16. So if I check out the number of squares I have here, so I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so it only goes up to 15. That's pretty close to what we need. We need to get up to 16. And because of that, I'm just going to say every box there counts as 1. It's okay if I can't quite fit that one on there. Sometimes you're not going to be able to fit all your data on the graph there, but if you want to make a nice graph, kind of spread it out, then you might be stuck with that situation. So I'm going to go, so there's 1, 2, because I'm counting every box as 1. So again, I'm labeling every other one. All right, now I'm ready to start plotting those points. Okay, so let's see. At 0 rides, you're at $6. Okay, at 1 ride, you're at 8. 2, we're at 10. 3, we're at 12. 4, we're at 14. And if I went to 5, that'd be like somewhere up here. So I can kind of guesstimate that one. All right, use your straight edge, connect them. And if you look at this, this is the graph that results. Okay, so next, if I'm going to come up with an equation for this one, I need to start off with, remember, our Y equals, and there's always going to be an X, okay? We just got to figure out what the unit rate is that goes there. And then in the back is if you had any starting point, which means at 0, this is your starting point, the total cost was $6. So I need to put a +6 back there, which represents that $6 to get into the fare. Okay, the number in front, that's our unit rate. So the unit rate was the $2 per ride. Okay, so that's just going to be put right there in that blank, so we get 2x. So the equation for that is y equals 2x plus 6. Okay, or, if you wrote it as y equals 6 plus 2x, that's the same thing. Okay, however, it's not really proper format because they will usually put your x in front. And when we get to graphing lines, we always want to put it in this form. Okay, so start getting the habit of putting it in that form. However, if you put that answer down on a quiz, this will also be marked as acceptable. Okay, letter A, what is the rate of change? Okay, so the rate of change means what is going on every one of something. So you see the rides went up 1, total cost went up 2, plus 1, plus 2, plus 1, plus 2. So the rate of change, again, is the y over the x. And we see what's happening every time here. You're getting $2 for every one ride, which we just talked about up there. Okay, and that's exactly what it represents, $2 for every one ride. Okay, letter B. Letter B asks, what is the y-intercept of the graph? And the y-intercept of the graph refers to where does this line touch the y-axis. So right here, this is our y-intercept. It's touching right there. So we could say the y-intercept is 6. Okay, where do you see the y-intercept in the table? Well, we see it, the y-intercept 6 is next to 0 for the x. So we could say in the table, it's next to 0 for x. The table is next to 0 for x. Where do you see the y-intercept in the equation? Well, the y-intercept in the equation is usually in the back there. So we can say that's 6. It's in the back of the equation. Okay, letter C. How would you change the context where the relationship between total cost and number of rides can be modeled by the equation y equals 2x? So they say, how can you change the story so you just have this equation? Notice it's different than this one up here. And what they left off was that plus 6. So that would mean the story would change. There is no admission fee. Okay, so there's no admission fee. The ride still costs $2, but there's no admission fee. Letter D. How would you change the context? Again, how would you change the story so the relationship between total cost and number of rides can be modeled by the equation y equals 6? Well, this one, they don't give you an x or anything. They just give you that 6, which, remember, that's our starting point. And the x and that 2 represented, the cost per ride. So with something like this, you would say it costs $6 for admission, and the rides are free. Or maybe you paid $6 to get into the place and they gave you like a wristband, which was good for free rides. Okay, go ahead and turn the page. So we're going to page 64. Okay, on page 64, it talks about you're taking a road trip. That's the title of our story. You start the day with a full tank of gas. Your tank holds 16 gallons of gas on your trip. you use 2 gallons per hour. Consider the relationship between time, so time in hours, and amount of gas remaining in the tank. Okay, so again, we see these two parts that we need to put over here in our table. Okay, usually the number of hours will always be in your X side. So we put X over here, and then we can say this is our number of hours. And then our total amount. So total amount of money, total amount of something. In this terms is gas. That's going to be our Y. So we could say amount of gas. Okay, you start the day, which means you start the day, you spent 0 hours driving. And when you start the day, you got 16 gallons of gas. So we can put 16 there. Maybe I should say up here too, amount of gas. I'll put G for gallons. Okay, now at 1 hour, what happens? Well, as you get going, you see you use 2 gallons per hour. So if I had 16, I used up 2. That means I only got 14 left. Okay, and if I continue, at 2 hours, same thing, you go ahead and subtract 2. So 12. And I want to continue up through 5. So at 3, again, we're going to be down to 10. At 4, we're going to be down to 8. And at 5, we're down to 6. All right, so let's go ahead and graph that. Looks like a very similar graph from before. So let's put a 0. Let's put an X. Let's put a Y. And then, again, X, I only need to get up to 5, so we can label it like we did before. 1, 2, 3, 4, 5, 6, 7. And then I see I need to get all the way up to 16. So if I recall correctly, we could only get up to 15. Because I do want to show this 0, 16, I'm going to change my scale a little bit. So I'm going to say that instead of every box being 1, every box is going to be 2. Okay, so if every box is 2, so 2, 4, 6, 8, 10, 12, 16, 20, 24, 28, and so on. Okay, graph this. At 0, oh, don't forget, we also need to put our labels. I almost forgot that. So I'm going to say down here, number of hours. And then over here, I'm going to say amount of gas. I'll put parentheses G for gallons. So at 0 hours, you're at 16 gallons. Okay, at 1 hour, we're going to be at 14. And then at 2 hours, we're at 12. 3 hours is 10. 4 is 8. 5 is at 6. And that's where our data stops. All right, so let's go ahead and use our straight edge. We do need to go ahead and bring this all the way down as far as we can go. So extend it out. Okay, don't forget that because this is proceeding down like this and it's a real world problem, eventually, your car's going to run out of gas. So it's not going to go into the negative gallons, which is the reason why we're not going to put a arrow on the end there. All right, so let's go ahead and write an equation for this. So we're going to come over and put y equals. And remember, we have our x. Okay, so what was our starting point? We looked where x was 0. And where x was 0, the number was 16. And it's a positive 16. So I'm going to put plus 16 down here. Okay, next is the rate of change. Well, what's happening? Every hour, you're going down 2. Every hour, you're going down 2. And if you're going down, that's represented by a negative. So the equation would be y equals negative 2x plus 16. Okay, letter A, what is the rate of change in this problem? Well, the rate of change we just talked about is negative 2 gallons, and we could say per 1 hour. So again, we're comparing it to one of something. You're losing 2 gallons every 1 hour. Okay, letter B. What is the y-intercept of the graph? Hopefully you answered 16. And what is it? It is also, again, we see it in the y-intercept in the table, next to 0 for x. In the equation, we see it in the back of the equation. And then what does the y-intercept represent in the story, in this context? So it means you started with 16 gallons of gas. Okay, letter C. How would you change the equation if your tank held 18 gallons and you used 2.5 gallons per hour? What would the equation be? And in this case, hopefully you said y equals, you were using 2.5 gallons per hour. So that means you're going to be negative 2.5x, but you started with 18. So that'd be plus 18 there. Okay, what would that do to the graph? Well, if we start up there at 18, you start a little bit higher. Then every hour you went down 2.5. So if I went down to, so 1 hour, so 18, I'd be about right here. And then at 2, be about there. And at 3, be about here. Okay, so if you look at the graph there, what it's doing, it's making it a little bit steeper. Okay, so what would change to the graph? Makes it steeper because of the higher. So it makes it steeper because of the higher rate of change. Okay, guys, that is it for today's lesson.